Hi everyone, this lesson is an Algebra 2 Trig Advanced review for the Chapter 3 test that you are going to be taking this week, and it also includes a station review. So let's get started. The first question says, find k if you have this equation and is divided by x minus 3. So the first thing you're going to do is we know that this is going to be a 0, and we're stating that it will be a 0. So that being the fact that this is going to be a 3 in here, we're going to put the number 2, negative k. We're going to put negative 4 and then negative 1 here. And our options, or whatever our objective is to take whatever our value is down here that we get and set that equal to 0 so we can solve for k. So what we're going to do is we're going to add down, so there's 2, and multiply across. And then we're going to add down, so that's negative k plus 6. And then we're going to multiply across, and so we're going to get negative 3k plus 18. And then I'm going to add down, and so I'm going to get negative 3k plus 14. And then I'm going to multiply across. So I've got 14 times 3, so that's 42. So that's going to be 42. And then negative 3k times 3 is negative 9k. And then we're going to add down. So I'll have 41 minus 9k. And then I want to set that equal to 0 so that I can solve for k. So I'll have 9k is equal to 41, and then I'm going to divide by k. So k is equal to 41 over 9. And then that's what k is equal to. I think that most of you will be able to work this out up until you get to here. And then what happens here is you may or may not, hopefully you're not going to forget that once you've seen it, is set that equal to 0 so that you can solve for k. Okay, because this is a 0, I'm stating that that's a 0. That's how I can set that equal to 0 because it is a factor. The next question says, using the rational zeros theorem, list the possible combinations of zeros. So we're going to use this value here. So we're going to say plus or minus 1, factors of 5, plus or minus 5, divided by factors of this value here, which is plus or minus 1, and then plus or minus 2. Now, if you leave your answer in this format, you're not going to get full points for that because I want you to list all the zeros. You can list them as plus or minus, but you're going to list them. So you'd say plus or minus 1 over 1, which is 1. You're going to say plus or minus 1 over 2 because it's this and this. See, 1 over 2. You're going to say plus or minus 5 over 1, which is just 5. And then you're going to say plus or minus 5 over 2. And so those are all my factors or combinations of zeros that I could actually try to divide into this equation. The next question says, given this equation, graph and find. So graphing this equation, let's see what we've got. An x plus 1. We have over this, which is a difference of 2 squares. So that's going to be x plus 6 and x minus 6. So I have nothing that I'm canceling out. So that means that I have no holes. We do have this value up on top, which is my x-intercept. So that's going to be at negative 1, 0. If you're not sure how to find that, you just take that x plus 1, the top the numerator, and set it equal to 0. You'll get x equals negative 1, which is right here, and then 0. The y-intercept is going to be 0, comma, right? So when you set x equal to 0, that's like these are gone here. And what's left is negative 1 over 36. Okay. Then we are going to look for our vertical asymptotes, which is always our denominators, what's left after I factor and cancel. So we're going to have a vertical asymptote at x equals negative 6, and I'm going to have a vertical asymptote at x equals 6. You need to write it out like that because if you just write the number 6 and then negative 6, you're going to get that wrong. It is bottom heavy. The variable on the denominator has a higher power than the one on the numerator, which means that my horizontal asymptote is going to be at y equals 0. So drawing in my horizontal asymptote, there's that. It's right there. My vertical asymptotes are going to be at negative 6 and positive 6. We have some x-intercept at negative 1, 0. and we have a y-intercept at 0, negative 1/6. We don't have any squared values, so it does look like my graph is crossing my axis like that. Well, it probably is a little bit more like that. And let's see, we also have so if see, this is negative 6. At this value right here, see this x plus 6, if there was a 2 there, there isn't, but if there was a 2 there, then my graph would come up like this. It would come up like this, right? With the multiplicities, the even is like a tangent kind of thing, but it's more tangent to the axis than it is anything else. But since there's no 2 there, right? There's no 2 there, then it doesn't do that, okay? So that's not an option. So what my graph does do is it does this. Likewise, at 6, there's no squared term here, so it's just going to be up like that. Otherwise, it would come down. You see that? I would come down to meet this value down here. It would come down. But because there's no value down there, right? There's no quantity squared or no even multiplicity, it's not going to do that. Okay, next term. Your job is to write a polynomial function of the lowest degree in factored form that has these zeros. So you would say f of x, start off with f of x. We're going to go x minus 4. I'm going to hold off on this for just a minute. I'm going to use the square roots. Remember, they come in pairs. So that's going to be x plus the square root of 5 and x minus the square root of 5. Okay, this value here is going to be x minus. And those are all going to start off like this. See that? X minus, okay? And what's going to be on the inside is going to be the quantity 2 plus 3i and then 2 minus 3i. Okay, see how that works? And so we're going to have, so you've got those quantities within. So you've got x minus that. So what happens now is we're just going to simplify. So we're going to have x minus 4. We have x plus the square root of 5. We have x minus the square root of 5. And then we're just going to distribute and simplify a little bit. X minus 2 and then minus 3i. And then we have x minus 2 and then plus 3i. And that's the smallest, that's the lowest in factored form. Parts of the test may ask you to multiply those values out, and it certainly wouldn't be as difficult as that, but you might have to do something similar. Identify the asymptotes. So for this problem right here, I'm just going to start off by factoring that, and I'm going to get x minus 5 all over x plus 3 and then x minus 2. All right, so now that we've factored everything here, write everything that you know. You know that you've got vertical asymptotes, and those are your denominators. So you're going to say at x equals negative 3, and you've got one at x equals 2. Now you look at this and see the denominator has a higher power than the numerator. That means I have a horizontal asymptote at y equals 0. If this had also been a 2, like if they had both been squared, my horizontal asymptote would have been at y equals 1. Okay, but it's not, so we're going to erase that. My x-intercepts are what's ever on the numerator, so I have 1 at 5, 0. A y-intercept, I'm going to go back to the original equation up here, okay? And I'm going to do this, set x equal to 0, and that's what I have left is 5 over 6. So 0, 5 over 6. And I think that's all I'm asking for that. So if we were to start graphing this, right, we would have a vertical asymptote at negative 3, which would be down this side. We would have a vertical asymptote at x equals 2, which is here. We have a horizontal asymptote at y equals 0. We have an x-intercept at 5, 0, and we have a y-intercept at 0, 5, 6. Now, right here, you really don't have a lot of information. And so what I would suggest at this point is to plot points. You have to plot points because you will never get this graph like this unless you plot points. We don't have any holes because nothing is canceled out. So you just are left with 2 points here. You're not really sure what that's going to look like. Okay, so you have to plot points. Now, I don't believe there's something this difficult where there's actually like not any points on that where you have to plot all the points, but it's just something that I do need you to be aware of. I end up getting this is my equation right here. So if I were to look at this right here, you've got let me move this, the correct place right there. So that's pretty much what your graph is going to look like. It's going to come down this way to the left, It's going to go up like this, and then it is actually crossing my horizontal asymptote right here at 5, 0, right there. So this is sort of what your graph looks like. Okay, that's kind of cool, right? Okay. The next question says, solve the inequality. So any kind of inequality, your first step is always to set that equal to 0. So in doing that, we're going to get 4x squared minus 9 is less than 0. I do notice that and recognize that this is a difference of 2 squares. So that means that you're going to have 2x plus 3, also 2x minus 3, and that's less than 0. Okay. Sorry. You're going to do sign pattern testing. I need 0. So we're going to set both of these equal to 0. So setting that one equal to 0, we're going to get 2x equals 3. X is equal to 3 over 2. So that's going to be 3 halves here. And then when I do this one, I'm going to get negative 3 halves. Because one's positive and one's negative, I am going to choose 0 to plug in and test my sign patterns. So I'm going to plug in 0. So I'm going to get 0 times 2 is 0. 0 plus 3 is 3 times negative 3, which is negative 9. And ask yourself, at 0, is negative 9 less than 0? Yes. So therefore, at 0, it's less than, okay? And so therefore, my graph is going to look something like this. So go back to the original equation, which is this, and you ask yourself, I know it doesn't actually say this out loud, but it does. This is saying, and you have to know what it's asking you. It's asking you this. Where is your graph? Less than 0. That's what they're asking you. Where is it? And so you would say, well, it's less than 0 in here. Okay? So it's less than 0 in here. So where is that? Okay, because that's where it is. That's asking you, what's the interval for that to happen? So you're going to say it's a less than, so it's not brackets. You're going to say, well, it's negative 3 halves to positive 3 halves. And then that's where it's less than 0. Just keep a note that had I graphed this, right? Think about what a parabola looks like. This is a quadratic, right? Remember when we did quadratics a couple of chapters ago? You know what a quadratic looks like, and negative 9, that's my y-intercept way down here. So you know that your graph kind of looks like this anyways, right? And then think about this. Where is the graph less than 0? Here. Okay, that's all that. And that's 3 halves here, and this is negative 3 halves here. But anyway, this is my answer, okay? So the next question says, there's my equation, and find everything for that. So I'm looking at this. This is done on top, but on the bottom, it looks like I can do factoring by grouping. So I'm going to factor out an x squared, and I'm left with x plus 3. I'm going to factor out a negative 4, and I'm left with, again, x plus 3, which is good because you want those two values to be the same. I get x squared minus 4 times x plus 3, and then I'm going to have x plus 2, x minus 2, because that's a difference of 2 squares, this part right here, and then I'm left with x plus 3. So it doesn't look like anything's canceling out because I have an x minus 3 on the numerator, but an x minus down here. Okay, so don't mess with that. That's done. So what I have is a lot of asymptotes. I've got a vertical asymptote at x equals negative 2. I have one at x equals 2, and I have one at x equals negative 3. Looking at the original equation, it looks like the denominator has a higher power, right? So then my EBA, or horizontal asymptote, for this problem is going to be y equals 0. I have no holes because nothing canceled out when I, x minus 3 over this value here. Nothing's canceling out. X-intercept, what's on the numerator, so that's going to be at 3, 0. The y-intercept is going to be from the top from the top, we're going to have negative 3 over negative 12, which is going to be 0, comma, 1 over 4. So we have 0, 1/4. We have 3, 1, 2, 3, 0. Okay. I have vertical asymptotes at negative 2. Okay. So there's one vertical asymptote. I have a vertical asymptote at 2. There's another asymptote right there. I have one at x equals negative 3. And then I've got a y equals 0. So I have a lot of stuff happening here. So again, I just want to make really, a strong move here. I mean, again, this is not going to be something that I may not ask you this difficult of equation with all of these asymptotes on the test. However, the fact that you do need to be able to factor x minus 3 and then factor these denominators. So you've got x minus 2, x plus 2, and then you have x plus 3. That's something that you need to be able to do, all of this stuff right here. And then something like this, you're going to have to plot points. And that's just something you're going to have to do. And you may not have to plot as many points as something like this. But for this graph right here, this one ends up looking something like this, okay? And this is the kind of thing that, you're going to have to plot. You're going to have to do this. This looks like something like this. Anyway, again, this is kind of a tricky question, but the main goal for this problem is to be able to get to this point and to know what are your vertical asymptotes, what are your horizontal asymptotes, your x-intercepts, and all of that. That's what I'm going to be looking for this type of problem. For this problem, though, this one's a cubic. You've got x cubed plus 1. The power on top is higher than the one on the denominator, which basically means that for this problem, I'm going to have to divide to find my end behavior. We do know that we have a vertical asymptote at 0. See that right there? That makes it 0. I don't have any holes, so my vertical asymptote is going to be at x equals 0, which is right here. Okay. Remember that if I were to factor this, right, this would be x plus 1. Remember, same, opposite, plus. Okay, so we know this is x. So same sign, same, opposite, plus. So this would be x squared here. This would be 1. This would be 1 times x, which is here. I do have one real x-intercept, which is at negative 1, which means my graph does cross at negative 1. So my end behavior, I'm going to have to find that equation, and I'll do that just in a minute. So I have negative 1, 0. I do have my y-intercept, I can see is already an asymptote, so this is probably undefined. And if I plug in 0, that means I'd have 0 cubed plus 1 over 0, which 0 on the denominator does mean that it's undefined. Additionally, let's find our end behavior asymptote. So if I were to do that, I would be dividing. So let's see. If I just divided long division, right, I would get x cubed. I'd have no x squared. I'd have no x, and I'd have plus 1. And this is really only going to go one step here because x squared here, and I'm going to get x cubed, and then all of these values are going to be 0. So basically, my end behavior is y equals x squared, which basically means that this graph right here is going to be going up like this and like this. So this is my EBA. That's going to be that asymptote that looks like that. So again, we actually did this one in class. So just to reiterate, it probably is when we plotted points, we got something like this where it followed the asymptotes. And then I believe we also plotted some points in here from 0 to 1, etc. And we ended up getting some values in here. And then so I drew the graph. So this is the graph right here, what we ended up getting. And plotting points, this is just like a more zoomed in look. So this is our negative 1, 0. Here is our end behavior graph like that. And then I believe what I remember is our graph going inside here. But the only way you're going to know that there's a graph inside here is if you actually plot some points. So I do recommend, again, plotting points just to make sure that your graphs are right on target. For this problem right here, we have two problems separately. This one is going to have a vertical asymptote at x equals 5. see how these have the same power? That means that my end behavior, or my horizontal asymptote, is going to be at y equals 2. I don't have any holes. Nothing's canceling out. An x-intercept at 0 here. Set that numerator equal to 0, and I'm going to get negative 3/2. Here, set x equal to 0, and I'm going to get negative 3/5. So plotting those points at 0, negative 3/5, somewhere down here, negative 1.5, 0 there. Y equals 2 is going to be that way. X equals 5 this way, okay? And it looks to me like my graph is actually going to swing around like this, and at the same time swing around like that, okay? The reason why I know that it's not going to swing this way, okay, people, is because, see this here, if these were together, this would have to be a multiplicity of 2. And because there's no multiplicity of 2 happening there, it's not going to come together like this. It's not coming up like that, all right? However, for this problem, this one does, if you've already noticed, see the squareds here at 0 squared. So at 0 at my vertical asymptote, right? I've got a vertical asymptote at x equals 0, but it's squared. So that means that if this graph here is positive, then that value, okay, is going to go like this, all right? It's going to go up like this, okay? So what's going to happen, okay, I can't talk, Tad. All right, so what's going to happen here is we have an end behavior at y equals 1, okay, because see how these are the same values like that. X-intercept, this one here is x squared equals negative 1, which basically means x equals plus or minus the square root of negative 1, which is an imaginary number. So that also tells me that for my x-intercepts, they're not crossing the x-axis. So that's happening. This is imaginary, so there's no x-intercepts. And my y-intercept, additionally, we already know, see here, that my that I have a vertical asymptote right on my intercept. So therefore, I can't have an intercept because it's undefined. And if I were to plug in 0 for x, you see, it would be 0 squared over 0, right? 0 squared plus 1, which is 1, over 0, which would be undefined. So you must know, if you are just graphing that, right, starting off to graph, you know that you have an asymptote here. You know you have an asymptote here. You know that your graph does not cross the x-axis because, see here, it's imaginary. You also know that at 0, right, you've got a multiplicity of 2, which means that it's got to come up. So your graph is going to come up and do this kind of thing like that, okay? It's got to. It has to. And it's not going to touch the, of course, it's not going to touch the asymptote. I see that I got kind of close to that, but it's not going to. Just a note, I did graph these for you. See, this looks something like this, what I just drew. There's my y equals 1. Just a note here, had this been, see this x squared plus 1, had I had a negative sign out front, like this value, like a negative out front, right? That would have changed this and moved this. See how it would have been down instead of up. I don't know if you can see that. Let me move this up. So it would have been going down like that. Okay? All right. Okay. So the next thing that we did was we worked out some stations. And so students went around the room. They worked out stations. And I thought this was kind of a cool little picture here. I don't know if you can see that, but I liked it. So these were around the room stations. So I'm going to get started going over some of those. And let's see how you guys did on that. Okay. So the first problem says solve this inequality. So in order to solve this inequality, the first thing you do need to do is to take this 1 and move it over to the other side. Okay. And in doing that, you've got x squared minus 8x plus 7 over x squared minus 4 minus 1 is greater than or equal to 0. We need a common denominator. Common denominator is going to be x squared minus 4. So we have x squared minus 4 over x squared minus 4. And so now I just have to simplify this. I'm going to get x squared minus 8x plus 7. And then I have to take this minus sign and distribute it. So then I get a minus x squared then a plus 4, okay? And this is all over x squared minus 4 and greater than or equal to 0, okay? The next thing is that we would do is we would simplify, and my x squareds are going to cancel out, and I have 7 plus 4, which is 11. So on the numerator, I have negative 8x plus 11 over x squared minus 4, which is going to be x plus 4 and x minus 4. Or excuse me, I'm sorry about that. That's going to be x plus 2 and x minus 2. So x plus 2 and x minus 2 and greater than or equal to 0, okay? At this point, I can factor out a negative 8. And in doing so, I'm going to move up to the top here. I would get negative times the quantity, negative 8 times the quantity x. Do I want to cancel out, or do I just want to take out the negative sign? Yeah, I might as well. So this is going to be negative 8 times x minus 11 over 8 divided by x plus 2 and x minus 2 greater than or equal to 0. And what I'm going to do is right here, see this negative 8? I would divide everything by negative 8 to lose that, move it to the other side. And I would then have x minus 11 over 8 divided by x plus 2. Then I have x minus 2. But this now becomes less than or equal to 0 as I divide by negative 8 on both sides. And it's a negative, so that's going to change my sign. So this is what I have here. I'm going to use sign pattern testing, and in doing so, I have positive 11 eighths. So, oops, so let me fix that. So right here, I'm going to have positive 11 eighths. I have, which is what, 1 and 3/8 is what that is. I'm going to have a positive 2, and then I'm also going to have a negative 2. And so I'm going to plug in a value. I'm going to try 0. So here's 0. 0 is here. And I'm going to ask myself, if I plug in 0, what am I going to get? So if I plug in 0, all right, I'm going to get 0 minus 11 eighths. So that's going to be negative 11 eighths, okay, divided by 2 times negative 2, which is negative 4. So this is over 1. Okay, so negative 4 over 1, which is negative 1/4, so times negative 1/4, which basically means it's positive 11 over 32. Is this number less than or equal to 0? So the answer is no, it is not less than or equal to 0. So therefore, if it's not less than 0, that means it's greater than 0. Okay, so then this is going to go all through there like that. And now the question is this. The question is, where is my graph? Go back to the original equation, right? Where I'm all over here, right? Where is my graph less than or equal to 0? Well, it's less than or equal to 0 here. It's also less than or equal to 0 here. And so you'd have to say, well, where is that? Okay, so that value where it's less than or equal to 0 is going to be parenthesis negative infinity to negative 2, parenthesis union, and it's going to also be at 11 eighths to 2. Now, here's the thing. I didn't put any brackets or anything in there yet, but what I want to make you conscious of is this. If my values on the denominator, okay, are asymptotes, correct? Vertical asymptotes. What that's telling me is that I can never touch those values. Those are asymptotes. So at 2, these have to be parentheses. Both of these here, negative 2 and 2, have to be parentheses. At negative infinity, it has to be a parenthesis. But at 11 eighths, it doesn't. And because this value here is less than or equal to, this value right here, okay, is going to be a bracket. Okay, so that's my final answer. This one says use long division. So basically, using long division to solve this, we can do that. Let's see, we would say x plus 2 outside, okay? And then what you would do is then plug in, make sure all you have placeholders. So you've got x to the 4th plus, I'm having some trouble writing right now. So we have x to the 4th plus 3x cubed plus 3x squared plus 3x plus 2. And then we're going to divide that out, okay? So the first thing we're going to do is x times what is x to the 4th power, and that's going to be x to the 3rd. And then you get a number up on the top, and you're going to multiply it through. So x cubed times x, which is x to the 4th, plus 2x cubed. And I'm going to, as soon as I get this value, I'm going to subtract the quantity. First term cancels. 3 minus 2 is 1x cubed. Bring down the next term, which is 3x squared. X times what is x cubed? So that's going to be x squared. X squared times x is going to be x cubed plus 2x squared. I'm going to subtract that quantity. First term cancels. 3 minus 2 is 1x squared. Next term comes down, plus 3x. X times what is x squared? Well, that's going to be x. X times x, x squared. X times 2 is plus 2x. I'm going to subtract the quantity. These cancel. 3x minus 2x is 1x. Bring down the next term, which is plus 2. X times 1 is x. 1 times x is x. 1 times 2 is plus 2. I'm going to subtract this quantity. I have no remainder. Therefore, this is my answer. Whatever, this right here is my quotient. I have no remainder. I mean, I could write it with a remainder. I just write plus 0 over x plus 2, but there's no need for that. The next question says, solve the inequality. And so for this problem right here, I'm going to lift this up a little bit higher. Remember, anytime you're trying to solve an inequality, you do need to set it equal to 0. So right now, I'm going to start over here. So we have 2x minus 5, that's a quantity, minus 3 times x minus 2. 3 over x minus 2 is less than or equal to 0. I need to get a common denominator. My common denominator is going to be x minus 2. So I'm going to be multiplying this by x minus 2 over x minus 2, because I can multiply by 1 in any form. In this form I'm choosing is x minus 2. I need to FOIL. So we're going to get 2x squared minus 4x. And then I'm going to get minus 5x plus 10 minus 3 all over x minus 2. And then that's less than or equal to 0. So what I have is 2x squared minus 9x plus 7 all over x minus 2 is less than or equal to 0. I'm guessing this is going to factor. I'm going to have to try. Let's see. 2x, I'm guessing it's going to be a 7 and a 2. 7 and a 1, so 7. So 2x minus 7 and x minus 1. Let's see if that works. Negative 7 and negative 2 is negative 9, so that check, that works. X minus 2 less than or equal to 0. So what I have now are all my zeros, actually. So what I have, the zeros that I have are 1. Here's 1. See this value here? That's going to be a 2. So I have a 2. And then this value here, 2x minus 7 equals 0, is 2x equals 7, right? And then x equals 7 over 2, which is 3/2. So actually that's going to be over here. So what I want to do is, I thought I would have a negative number, which I don't. I need to pick a number in between here, and I'm going to choose 3. So choosing the whole number 3, okay? I need to plug that into my equation. And so I'm going to get 2 times 3 minus 7. What is that? 6. 6 minus 7 is negative 1 times 3. So I'm plugging it down here. 3 minus 1 is 2, so times 2, over 3 minus 2, which is 1. So this is going to be negative 2. So this is what I'm asking myself. Is negative 2 less than or equal to 0? So if negative 2 is less than or equal to 0, that's correct. So at 3 right here, I'm asking myself, is this less than or equal to 0? And the answer is yes. So it is less than or equal to 0. Now, because I have no multiplicity, so nothing's bouncing off, this is just going to go up, down, negative, positive, etc. Okay, it's going to go like this. So now my final question is go back to the last equation where you're at here, and you ask yourself, where is my equation less than or equal to 0. So it's less than or equal to 0 here and also here. Now you have to say, well, okay, well, where am I? Where am I at less than or equal to 0? So I'm here from negative infinity to 1. Is 1 on my denominator? It is not. And because this is less than or greater than, this becomes a bracket. And also it's less than 0 at 2, but 2 is an asymptote. So 2 is going to be a parenthesis. And then 2 to 3.5. And at 3.5, that's a numerator, and that can also be a bracket. Okay. The next question says, graph this equation. So I see my answer already there. So we're going to go f of x is equal to, I need a factor. So we have x, I'm going to say plus 3. We have x minus 2 over this value here, which is going to be x, I'm going to guess it's minus 5, and then x plus 4. And so graphing this equation, what I do see is that I have a negative 3 is an x-intercept, and I have a 2, which is an x-intercept. I have asymptotes at positive 5. I have asymptotes at negative 4. I notice that these two graphs, see my x's, so they're the same. So that means I have an asymptote at 1, okay? Also, additionally, I have an asymptote at, no, I have a point, which is my y-intercept is going to be at 0, 6 over 20, right? Which is going to be divided by 2, which will be 3 over 10. So at 0, so right here. So actually that looks like that is not crossing that horizontal asymptote. That's what it looks like to me. And so for this problem right here, it looks like this is happening right here. See how that comes back around? So that to me is what it's looking like. Additionally, because there's no multiplicities of 2, then my graph is not doing this. See how it would be coming down like that? It's not doing that because I have no even multiplicities. So then therefore my graph would be coming up here even though I'm not plotting any points. And of course I would plot points just to make sure that I have the right answer, but that's what I'm looking at right now. The next question is solving this inequality. This one, I would move this over to the other side. And let's see, we need a common denominator. So common denominators, we've got x plus 3, x minus 3. Moving this, we've got plus x plus 2 over x plus 3. And so for this one, I need another denominator. And then moving the 2 over, that's over 1. And then I've got less than 0. So these denominators, this one is going to need everything. X squared minus 9 over x squared minus 9. But this one is actually, because I have an x plus 3, it only needs an x minus 3. So x minus 3, x minus 3. Again, this problem is a little bit intense. I'm not asking something this difficult, but if you can do this problem, then you can do any problem on the test. So you're going to be in good shape. Now that I have a common denominator, I'm just going to do this, and I'm going to say, well, my common denominator is x plus 3 and x minus 3. And then there will be less than 0 here. But on the top, I actually need to simplify that out, and it's quite intense here. So we've got 8 plus, and then I'm going to FOIL. So what is that? X squared plus minus 3x. So we've got minus 3x. We have plus 2x. We have minus 6. See this negative 2? That has to be distributed. So I've got minus 2x squared, and then plus 18. So what it looks like to me for this problem is I've got 1x squared minus 2x squared, which is negative x squared. So those are gone. And then I've got a negative 3x and a positive 2x, which makes minus 1x. Then I've got an 8, what's that, 18? Minus 6. So that's 2 plus 18 is 20. So then we have this happening, x plus 3, and then x minus 3. I might just decide to lose that negative sign out front. If I factor out the negative sign, let's see where we're at. That's going to give me x squared plus x minus 20 over x plus 3, and then x minus 3 less than 0. And yeah, I think that's my best bet, is to get rid of this negative. So I'm going to divide by -1. I'm also at the same time going to factor my numerator. So that's going to be an x plus 5. I've got an x minus 4. I've got this happening, which is leaving it like that actually, a plus 3 and x minus 3. And then this, if I divide by -1, this becomes greater than 0. I'm going to use my sign pattern testing right now. I've got so many zeros. Let's see, I've got a -5. I've got a +4. I have a -3, and I have a +3. And so I'm going to choose, I choose 0. And I'm going to say, well, let's plug 0 in. If I plug 0 in, I get 5 times -4 over 0, 3 times -3. So I've got -20 over -9, which is +20 over 9. And I'm asking myself, is my graph greater than 0 at that point? Is this number right here at 0, is that greater than 0? The answer is yes. So therefore, my graph is greater than 0, and it's going to do all this fun stuff here. So it's like a little snake here. And then, okay, so then you go back to this equation here, and this is what it's asking you, okay? Even though it doesn't actually say it, it's saying this, okay? Where's my graph greater than 0? So you're going to say here, here, and here. So that value is going to say it's going to be -infinity to -5, parentheses. These are all parentheses because it's a less or greater than, so you don't worry about brackets. With, what is that? -3 to 3 and 4 to infinity. Okay, cool. Graph the following equation. So for this problem right here, x squared plus 3x. So what I'm going to do, let's see, factor. Let's factor. Start factoring. I'm going to take out an x squared. So what I have left is x plus 3. I'm going to take factor the bottom, and that's going to be x minus 4, and then x plus 2. That's -8, -2. Okay. And so what we have are vertical asymptotes at x equal 4 and x equals -2. I have a top heavy. It's top heavy. Basically, that's telling me, see how the cube root here, the cube is higher than the square. So I'm going to have to divide to try to find my EBA, that slant asymptote, okay? I do have x-intercepts. Let me write those down. I have x-intercepts at 0, and also I have x-intercepts at -3, 0. Y-intercepts, looks like if I plug this in, 0 over -8, 0 divided by anything is still 0. It's not undefined unless the 0 is on the denominator. So my y-intercept is just 0, 0, which, oh, that makes sense because I already have an x-intercept at 0, 0. So let's say if I were to divide this would be, it looks awful. I mean, to be honest, to divide, but it really isn't, because if you think about this, look, this goes out front, okay, and then you divide like this, okay, this is not terrible. X cubed plus 3x squared plus no x plus nothing, right? You don't have to go very far because you're just looking for the equation of the line. So you're going x squared times x, right? You get that number up top, multiply it through. So now you have x cubed minus 2x squared, see, minus 8x. Look how far we got. We're all done. Subtract the quantity. These cancel. And then we've got, what do I have? 3 minus -2, which is positive 5x squared. And -0 minus -8, which is positive 8x, right? But that's not even going to be part of my equation, okay? Because now I'm going to go x squared times what is x is 5x, and that's going to be 5. And I'm done, and all I have to do is set that equal to y, and that's my EBA, okay? So that basically means that at 5, I'm going to start, and then that's my y-intercept. See that? That's my y-intercept. And I'm going to go up 1 over 1, so it's going to look something like this, right? We also, I'm going to move this over just a little bit. Oh, boy. Okay, maybe I just erased that. Okay, and then we also have a vertical asymptote at x equals 4, so that's up and down like this. Okay, this is happening like that, right? We also have a vertical asymptote at -2, so that's happening. What else do we know? This isn't a point, by the way. That's just where my graph crossed my x at my y-axis. We have, do I have any x-intercepts? Yep, here. And then at -3, 0 here. That was, what value is this? This is, that's 2. Okay, so that's a -2. So that means, let me move this over a little bit. There we go. Oh, not that, this. Okay, I want to move that over. Okay, because what's happening is right here, that there's a point here because this is -2. So there is a point at -3, 0. See that? And then we have this happening at 0, 0. Okay, move that back over. Okay, so trying to make some sense of this, I would definitely need to plot some points. Okay, so it is going to cross here. It's not ever going to cross your vertical asymptote, but totally fine crossing your horizontal and slant asymptotes. This is going to happen, look something like that. Truly, I really just need to plot some points for this just to make sure that all the points are going where I think they're supposed to go. But that's how you do that. The next question is actually finding the equation from the values that they give you. So I know that your copy is a little bit better than my copy, and it's really hard for me to see this, I know, especially without my glasses. But what it looks like, let me see what I think I see, is 5 here, 10. So that looks like 4, vertical asymptote at 4. So I'm going to write these out. So I have a vertical asymptote at x equals 4. It looks like I have a vertical asymptote also at 1, 2 at x equals -2. It looks like I have a horizontal asymptote at 1, 2, 3 at 3. So HA at y equals 3. It does look like I have a hole here. It looks like it's at 1, -5. So we're going to say hole at 1, -5. X-intercepts kind of looks like there's one here and here. So, and here. Looks like I have 3 x-intercepts. So my x-intercepts are going to be at -5, 0, -1, 0, and -3, 0. Okay. And I think that's all the information that I have. So making my equation, I got to put all this together. So f of x equals, I'm going to draw a big line because I have a lot of information. Okay, I'm going to put my vertical asymptotes in first. So we've got an x -4, and I've got an x plus 2. Horizontal asymptote at 3, the only way that's going to happen is if it's the denominator and the numerator have the same variable power. So we're going to have to get back onto you on that. I do have a hole at 1, so that means that this is going to be x -1, which also means that is x. There's an x -1 on the denominator. What else do I have? Oh, x-intercepts. I have an x-intercept at x plus 1 here. So x plus 1, that's this value. I have one at x plus 3. That's this value. And then I have one at x plus 5. Okay, wow, that's a lot. Remember, in order for this to be 3, my power up on top has to match my power on the bottom. And it looks like I've got 1, 2, 3, 4 power on top, which definitely means I have 4 power on the bottom, but I have no more points. So the only thing that I would recommend is that you look at your graph and see if there's anything that is doing this. Is there any kind of multiplicity where that's happening? And it does look like right here, see how these are both coming up in between this asymptote right there? and that's at -2, which tells me that I'm going to have this, see this 2? There is going to be a 2 here, okay? Because that's going to make this happen, okay? And now I've got 4x to the 4th power on the bottom, x to the 4th power on top. So that's my answer. I'm done, okay? So there's the value, all right? Oh, just a note, I can check for sure to check and see what I have by plugging in the hole and making sure that that works. Okay, given the polynomial, what do we know? We know that this is a cubic. This looks like 3x cubed minus 8 plus 7 is just minus x minus 2. Okay, it's asking me all the possible combinations. Well, it's a cubic. So you can either have your options for number 1 are you can have 3 real answers. You can have 2 imaginary and 1 real. And that's it. For the second part, what are the zeros? What are all the possible rational zeros? They're not asking me to actually find my zeros. They're just asking me to say what they might be. And so those would be this value here, the 2. So we're going to say plus or minus 1, plus or minus 2 over, and then this value here, which will be plus or minus 1 and plus or minus 3. So we got factors of this, and we've got factors of this. These factors go on the top. These factors go on the bottom, okay? And so all of the possibilities are going to be 1 over 1. So it'll be plus or minus 1 over 1. It'll be 1 over 3, so plus or minus 1 over 3. It'll be plus or minus 2 over 1. And it'll be plus or minus 2 over 3. So these are all my values. It's basically using the rational zeros theorem that are going to be possibilities for plugging in values to find the zeros. For this problem here, which of the following are true or false? So let's just factor to start off with. We know that if I factored this, I'm going to get x times the quantity 4x plus 1. Okay, and on the denominator, I'm going to start off with taking out an x, and then I get x squared plus 5x plus 6. I see that my x's are going to cancel. You see that? These cancel, those 2 x's. That means I have a whole at 0, because remember, that's just like x minus 0, okay, divided by x minus 0. And those are going to cancel out. So I do have a whole at x equals 0, so a whole at 0 comma something. I don't know where the whole is, but I have to plug that in. What else? Oh, I'm going to factor this. This is going to be x plus 2, yeah, and x plus 3. So far we've got the 4x plus 1 over this right here. So let's look at this. See how it's x squared over x cubed? See how it's bottom heavy? I do know that I have a horizontal asymptote at y equals 0, so this is true. Do I have 3 vertical asymptotes? No, I only have 2, so that's false. Is there a hole in the graph? Yes, that's true. The x-intercepts are 0, 0. Well, this is a hole at 0, 0, so I guess that is a x-intercept. I also have an x-intercept at, make this equal to 0, so that would be at -1/4, comma 0, so that's a true. A y-intercept, go back to the beginning. If these were zeros, right, I'd have 0 over 0. Hold on. Let's see, those already canceled out. So what is the question? The question is saying, what is the question? That I have a y-intercept at 0, hold on, I've lost my place. So for this problem at 0, 1, 6, oh, hold on. Yeah, here we go. And so 1 over 6. So yeah, if that was 0 and I canceled out all my x's, I'm going to have that value there at 0, 1, 6. Yes. And the domain, no, that's not true. You can't have all the, as soon as you have asymptotes, you can't have all real numbers as your domain because you have discontinuity there. So that's not going to happen. Okay, so the next question says factor the polynomial and then solve. So if we're setting this equal to 0, I'm going to see, does this factor by grouping? No. So it doesn't factor by grouping, so we're just going to start plugging in values. Okay, make good choices. We can try 6, 18. Remember, you've got plus or minus 1. These are our choices, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9. Did I get everything? Oh, and 18. So we have a ton. I'm trying -3, which probably because it works, I think. Let's see. 1, add down, multiply across, add down, multiply across, add down, so that's -6, multiply across, and there's 0. Okay, rock on. That works. X plus 3 is one of my factors. Now, this is what's left. 1x squared, see that? Plus x, plus 1x, minus 6. And I'm going to factor that. So we have x plus 3. We have x plus 3. We have x minus 2 equals 0. This looks like we have a double multiplicity, doesn't it? It looks like we have x plus 3 times x plus 3. And then we have x minus 2. So that means I have a 0. Here's my zeros, okay? I have a 0 at -3 with the multiplicity of 2. I have a 0 at 2 with the multiplicity of 1. And that means that my graph, if I chose to graph it, which might as well, 1, 2, 3, that means I have a 0 here. I have a 0 at 2. What's my y-intercept? -18, so way the heck down here. It's a cubic, so remember it's going to be upright. So my end behavior is up. That goes down. So that means it's positive. So we're going to go up this way. I do have something bouncing, or that's tangent, because there it's tangent, right? So don't forget. So at -3, it's tangent. That means that's because it's even here, tangent, right? Okay, so that means it's going to go down, come back up, and at -3, bounce right off of that. Okay, so that's what that looks like. Okay, almost done here. Find a polynomial that has a 5th degree. -3 is a 0. So we're going to start off right away. We've got -3 is a 0, so we're going to go x plus 3. It has a multiplicity of 2, so check there. 2 as a 0, so that's going to be x minus 2. The multiplicity is 1. You don't have to put that there, but you can. 0 is a 0. So my choices are x minus 0, and it has a multiplicity of 2. So I can so I can choose to add that right here, or I can choose to say, well, that's just x squared, and I'm going to put that out front. Okay, so here's my graph. Find a polynomial. This is 2 plus 2 is 4 plus 1 is 5. Just graphing that, so for fun, because math is fun. We're going to have a 0 here. Remember, that is a multiplicity of 2, so it is going to be tangent there. At -3, it's a 0, also multiplicity 1, so at 2, also a 0. Now remember, it's a 5th power, x to the 5th power, which means it is positive, so it is going to be up that way and down that way. So that means that we're going to go up this way, right? 2 is a multiplicity of 1, so that's going to go through here, all right? Remember at 0, it's tangent, so it's going to flip off of that, go back down, ricochet, back up. Oh, again, it's got a multiplicity of 2, so it's going to look something like that. Okay? And last problem. We have this equation. It's inequality again. We have 2x squared minus 3x minus 2 is greater than 0. I am going to factor this, and that's going to be 2x, 1 and 2, 2 and 1, plus 1, x minus 2. Let's see what happens here. Greater than 0. So let's check the inside. So x and negative 4x plus x is negative 3x, so that does work. Okay, so so what? Now we're done factoring, so we're going to make my sign pattern testing. I've got a 2, here's my 2, and this becomes 2x plus 1 equals 0, 2x equals negative 1, x is negative 1/2, so that's over here. I'm choosing to plug in 0, which is in between here, and I need to test it. So 2 times 0 is 0, plus 1 is 1, times 0 minus 2 is negative 2. Is negative 2 greater than 0? Is this value right here? So I mean, I'm saying negative 2, but I'm saying negative 2 when I plugged in 0, okay? So what I'm saying is this value here greater than 0, okay? And the answer is no, it's not greater than 0. So is it greater than 0? It's not. So it's not greater up here. It's not greater than 0. So therefore, it's below 0, okay? And I don't have any multiplicity, so there's nothing bouncing off of that. So the question is, back in the very, very beginning, is from here, where is my graph greater than 0? So it's greater than 0 here, and it's greater than 0 here. Where are you? You are at negative infinity to negative 1/2, and you are at 2 to infinity. And that's your answer. Because that's all it's asking you. It's asking you this question, and it's not, it's asking you this question even though it's not like actually saying the words. It's saying, where is it greater than 0? So those are the places that it's greater than 0. So, hey, good luck on your test. I sure hope this helped you. If you got through this, this was a pretty difficult review. You are going to be amazing on the test. I truly believe that. So good luck, get a good night's sleep, and I will see you soon. Let me know if this video helped you at all. I appreciate your feedback. Thanks for watching.